So hello guys. So let's see, in this video we are working on an application of boost converter. So what is this boost converter basically? So this is a device, it is used to boost the input voltage, at a higher level. Like my output voltage should be higher than the input voltage. So if I have application like where I want a higher voltage and my input voltage is lower, suppose output voltage is 12 volt and my input voltage, it's 5 volt. So if I want to convert this 5 volt to 12 volt, so I'll use a type of DC-DC converter that, that's known as boost converter. So basically what it does, like it takes this inductor, some passive components, and inductor, diode, and capacitor. And what it does, like it it stores the energy in the form of this inductor, and delivers it to the capacitor to increase the output voltage basically. So when I showed this switch basically, which is a MOSFET, high speed switch. So what happens, like energy will build up in this uh, inductor, and when switch turns off, so it is delivered to the capacitor. So that's how, like, the capacitor is able to uh, increase its voltage. So this additional energy goes and stored in this capacitor, which in turn increases its voltage basically. So we can see it, how the output voltage related to the input voltage. So the transfer function is given as this. We can derive from the equations, like current inside going through the inductor and whatever the current going outside, so that average will be zero basically over a period. So from that we can derive this formula. And so you can see, like, I want to double my voltage, so I will take the duty to be 0.5, and you can see my output voltage will be double of the input voltage. So in practical applications, you can see, like, I'll show you a circuit where it's used. uh, you can see in day-to-day life, like where we use this kind of converter, boost converter. So if you can see here, there is a one cell, lithium ion cell, and from there, we want to increase its voltage to uh, a higher level, like 3.3. I want to increase it to 5 volt, because there will be many part of my circuits that will be running at 5 volt. Like suppose I want to turn on relay, or if I want to turn on like some motor or LED, so that might need 5 volt. So you can see, like, so this is the source, this is the Vs, and this is my output voltage, which is 5 volt. Input is 3, between 3.3 to 4.2, and this is the input stabilizing decap, and output store energy storing capacitor, and feedback to, like, to set the output voltage. My output voltage will be the function of the internal feedback voltage into a resistor divider equations. Basically, it's like I set the value of resistor. According to that, I can have a output voltage, and this is the inductor to store the energy, and it's connected to the MOSFET basically. So it's turn and turn off, and it stored the energy and delivered to this output cap. So this is the actual implementation of this representative, circuit diagram of boost converter. This is the actual boost converter IC. That's how it's implemented. We put inductor, and the diode and the MOSFET are inside the IC, and we use for resistors for feedback voltage. Whatever the output voltage I want can be calculated from this formula, and uh, capacitor From data sheet we can see the what's the value of capacitor we may need for the particular amount of uh, current. So that's how we use it. And we can also have, like, we can also convert 5 volt to 12 volt also. What we have to do, we have to just change the value of this R1 and R2, and this capacitor ratings and this inductor ratings we have to take care of according to that. So just changing these parameters, we can have any output voltage from the given input voltage.